Hello guys, this is Makhdoom and this is Exhausted Nerd. Welcome to my channel. I will teach you Olympiad mathematics and we are starting out with number theory. If you have no idea about number theory and Olympiad number theory and you are a complete beginner, this is for you. We will start from absolute beginner level and we will do a lot of national level problems from around the world: India, Pakistan, China, British Mathematics Olympiad, Balkan Mathematics Olympiad, and much more. So let's just start with our first topic. Before starting out, I want to tell you the format of these videos in this playlist. So each video would consist, it would be very small video. I would just explain the concept, and the next few videos would be problems, okay, from around the world. Okay, so before starting out number theory, before starting out the topic of divisibility, I wanted to maybe there might be some people who do not know the difference between factor and multiple. I want to make it clear, since this is a huge thing requirement. Okay, so what is a factor and what is a multiple? So y is equal to ax when every single number can be written like in this form, right? So a and x here will be the factor of y, which means a divides y and x divides y. Factor and divisor means the same thing. It doesn't mean anything different. They are the same thing. So when I say that a is a factor of y, what I mean by this is a divides y. So 6, the factors of 6 are 2 and 3. That means 2 divides 6 and 3 divides 6. Again, factor means divisor. Okay, so if I say that x plus 3 is a factor of, let's just say x cube plus 5x square plus 6x plus 1, that means that x plus 3 would completely divide this equation with no remainder. This is what I mean when I say that it is a factor. And multiple, I can say that y is a multiple of a and x. In the other way you can understand this is y comes in multiplication table of a and multiplication table of x. So y is multiple of a and y is multiple of x. Okay, so this says an integer x not equal to 0, which is a non-zero number, divides y if there exists an integer such that y is equal to x, which primarily means the same thing that I taught you, that a is a factor if it divides y, x is a factor if it divides y completely, okay, and y is a multiple of a and y is a multiple of x. Similarly, 6 is a multiple of 2, 6 is a multiple of 3, and 2 divides 6 and 3 divides 6, okay. So with no remainder, 6 divides 2, 3, the 6, and there is 0 remainder. That's what I mean when I say completely divide. If a number doesn't divide completely, let's just say 6 is divisible by 4, and let's just say 4 ones are 4, and then you get 2 in the remainder. That means 4 is not a factor of 6. 4 because complete doesn't divide it completely. And how would you actually write 3 divides 6 in number theory? You have to learn this 3 divides 6. You can write it like this, okay, and 4 does not divide 6. This I have wrote here that x divides y, and it is read as x divides y, and similarly x does not divide y, it is read as x does not divide y. So 3 divides 6 and 4 does not divide 6, okay. So, and this is a new thing which is test of divisibility. Like if you want to check if any number is divisible by some specific number, you can use these rules. So a number is divisible by 2 if its unit digit is divisible by 2, and let's just say we have got this number. So is it divisible by 2? You just have to take the last digit, and if it is divisible by 2, then the whole number is divisible by 2. And similarly, same goes for 4. If last two digits are divisible by 4, then that number is divisible by 4. Okay, it is here 4 and it is here 6. And 8, if and only if 8 divides this last three digits. But have you ever thought why like this works? What is the reason this works? So let me tell you. So let's just say we have got a number 1 2 3 4 5 6. Okay, now why do we only check this number when we are checking the divisibility of 2? It's because we can write this number like 1 2 3 4 5 0 plus 6, right? Because this is the same number, we are just writing it the other way. And since here it is a 0, which means 1 2 3 4 5 into 10, okay, plus 6. Now look at this number, this huge number. Okay, this has a factor of 10, and 10 consists of 2 and 5. So this number will always be divisible by 2. Why? Because it contains a 2 in it. Okay, that's why we only check what's left. So if this is also divisible by 2, then obviously this whole number is going to be divisible by 2. And if I want to check if this number is divisible by 4, then I would do 1 2 3 4 5. No, not 4. 1 4 and then like 56. Okay, we have to check the last two digits. If they are divisible by 4, then the whole number is divisible by 4. So we can write this as 1 2 3 4 into 100. Okay, 100 will have a factor of 4. Okay, so 100 does have a factor of 4, which is 4 2s are 8 and 4 25. Okay, so this number will always be divisible by 4. This number will always be divisible by 4 because it has a factor of 4 in itself. Okay, and that's why we only check what's remaining, the last two digits. Same goes for 8, same goes for 5, same goes for every other number. Okay, 5 is divisible, any number is divisible by 5 if its last digit is 0 or 5. 25, if the last two digits are divisible by 25, then the whole number is divisible by 25. If last three digits are divisible by 125, then the whole number is divisible by 125. Yeah, this is pretty interesting. 3, if the sum is divisible by 3, then the whole number is divisible by 3. 1 2 3 4, is it divisible by 3? Now the way you can check it is 1 plus 2 plus 3 plus 4. If the sum is divisible by 3, then this whole number is divisible by 3. Sum is 3, 3 is 6, and 10. 10 is not divisible by 3, therefore this number is not divisible by 3. This number is not divisible by 3. And if sum is divisible by 9, then the whole number is divisible by 9. If it isn't, then the number is not divisible by 9. And now I want you to think about it and why it works. Just like we proved that why it works for 2, 4 and 8, can you try to prove and why it works for 3? Why it works for 3? Think about it and see if you can prove it. Now this 11, the divisibility of 11, it is pretty interesting. You can understand it two ways. So if there is some number 1 2 3 4, let's just say 1 2 1 2, okay, and you want to check if it is divisible by 11, the very first thing, which is pretty easy to understand, is that you have to take their sum in with alternate signs, and if that is divisible by 11, then the whole number is divisible by 11. What I mean by alternative sign is +1 -2 +1 -2. So this leaves us with -2. -2 is not divisible by 11. Okay, -2 is not divisible by 11, so it is not divisible by 11, therefore this number is not divisible by, therefore 11 does not divide this number. Okay, or you can say that sum of the difference of sum of digits on odd places and even places. So the odd places 1 and 3, this their sum equals 2. Okay, 1 plus 1 is equal to 2. And sum on even places, this 2 plus 2 is equal to 4. Their difference, if that is divisible by 11, then that number is divisible by 11. So that would give us -2, but -2 is not divisible by 11, therefore 1 2 1 2 is not divisible by 11. Okay, so this was just a basic thing. In SMC you might get some MCQs if that number is divisible by 4, or check if this number is divisible by 8. But it is also useful, man. It is useful. It does come in even greater questions, this 11 one. Okay, this is important. Okay, for example, let's just define a rule. If they give you this number, let's just say they give you 24, okay, and they want you to check if 24 divides let's just say 2 3 6. Okay, does 24 divide 2 3 6? The easiest way is that you have to do its prime factorization. Okay, first you have to do prime factorization. 2 12 is the 24, 2 6 is the 12, 2 3 is the 6. So you have got prime factorization 2 3 into 3. So if this number and this number divides this, then it will divide 24. Okay, like this whole complete number with power, I mean, like if 8 divides, so you can write it in expanded form. If 8 divides this and 3 divides, like both number must divide this for this to be divisible by 24. If either one fails, then it is not divisible by 24. Let's just check 3. For 3 you do the sum, so let's do the summation. 2 and 3 is 5. 5 and 5 plus 6 is equal to 2 plus 3 plus 6 5. It is 11, and 11 is not divisible by 3. So 1 failed, and we would say that 24 does not divide 2 3 6. So first you gotta take prime factorization. Okay, so first take prime factorization, and then you check if it is divisible by prime factorization. If so, then the whole number is divisible by. Now, properties, this is a very important topic, and this is the main topic. Those were just the overviews and not very important, but this is really important. So the very first property is more of a fact than property. 1 always divides any number. The number itself divides itself. Obviously 2 will divide 2, and any number a could be anything, any integer would divide 0. Okay, the second property is if b divides a, then like negative number would also divides that a, and b would also divides negative a. So if 2 divides 4, then negative 2 would also divides 4. Okay, the sign doesn't matter as much. This is a really important property, the third one. If a divide, this is a transitive property, and with those properties that are important, you have to memorize them. In like, you should know those property at fingertips, man, because these are used a lot in further questions that I would give you. Okay, we would do problem solving session, and you would see a lot of questions can be done using these properties. So the very first property is transitive property. If a divides b and b divides c, then a would divide c. And the proof is like b is a multiple of aq. So just like I told you, like if a divides y, we can write it as y is equal to ax. Okay, because y is a multiple of a. Okay, so similarly we can write this as b is a multiple of aq1, b is a multiple of a, and b is a multiple of c is a multiple of b. Okay, and we know the value of b. We can plug it in here. So if I plug it in here, you get c as a multiple of a, which proves that a divides c, because c is a multiple of a, just like I told you. and you can prove the other properties as well. I would tell you few properties that you have to prove, and it will improve your a lot of problem solving. The fourth property is if A divides C and B divides C, then AB divides CD, their product would also divide their product, which is used but not very much. If A divides B and B divides A, then A is equal to B, obviously. If 1 divides 2 and 2 divides oh no, if 1 divides no if 1 divides 1 and no, this property, yeah, this property is right. If A divides B and B divides A, then A is equal to B, which eventually means that if 2 divides 2, then 2 would also divide 2. Like it would only work if A and A is equal to B, otherwise it will not work. Like 2 divides 3, but 3 would not divide 2. It would only work if A and B are equal. And the sixth property, this is a really important property. It is very, very important. It is the most important property. You have to memorize this property, and this is the linear combination property. It says that if A divides B and A divides C, then A would divides B x plus CY. Let's prove it. So A divides B, we can say that B is a multiple of A, okay, AK1. And A divides C, we can say C is a multiple of A, okay. So now let's multiply. Here it is bx, so let's multiply with x on both sides, okay. Similarly, let's multiply with y here on both sides, okay. So now when we try to add both, you get AK1x and then you get AK2y, right? And then the summation would be a multiple of A, bx plus cy. If you take A common, you get k1x plus k2y, okay. So you can see that A is a multiple. You can let it A. So A is a multiple of, or you can let it L. So since A is a multiple of this, that divides this means, since this number is a multiple of A, that means A divides this number, okay. So we can write it as A divides bx plus cy, which proves our property above. The seventh property is just a converse of this property, and the property 8 is if A divides B and A divides C, then A divides their addition and also divides their difference. This is important property. Again, you have to memorize this, and from this because this is used in questions, man. Okay, so let's just say I give you two informations. I say that I am saying that A divides B, and I'm also, no, I'm telling you that A divides 10, and I'm also telling you that A divides B plus 10. So now I want you to prove that if A divides B. So what you can do is you can use this subtraction property to get to the prove that A is equal to B. So subtraction property is B plus 10, and then you subtract the other number, that like minus 10, and then you get A divides B, okay. So this subtraction property is very important. If A divides B and if A divides B and A divides C, then A would divide their difference, and similarly it would divide their addition as well. And yeah, this is what I proved. This is what I told you. Since like you can use this subtraction property to prove that A divides C, and again you can use here addition property to prove that A divides C. So this is just a part of it which is not very important to memorize, but this property 8, you have to memorize this completely. You must be fluent in this property. And the very next property number 9, it is known as bounding property, and it is very, very important, man. It is a must memorize bounding property, because it is used a lot. It helps a lot in solving question. If A divides B, then B is either equal to 0 or A modulus is less than B modulus. This property is used a lot in the questions, we would see. And property number 10 is if a divides b, then a divides b if multiplied with any integer. If a divides b and then if they are multiplied with any integer, they would divide that would also divide itself, because m would cancel out with m, leaving you with a. So it always works. Now property number 12, it is again a really important property. So there are actually how many properties that I called important? Property number 6 is very important. This is a very important property. Property number 8 is very important, and property number 9 is very important, and property number 12 is. So in total you have got only 4 properties that are very important. So the property number 12 says that if a divides b c, then either a divides b and or not and a divides b c, then either a divides b or a divides c. But note that there is a catch, which is a must be prime. Okay, so if I am writing 11 and it divides, let's just say x plus 3 and x minus 3. Okay, 11 is prime. Note this must be prime. Then I can use this case that 11 either divides x plus 3, 11, or it divides x minus 3. So this is what this property means. With the help of this, you get to solve so many questions on primes, composite number, and divisibility. Man, this is a very useful property. And 13 and 14 is also a pretty important property. It says if a square divides b, then a divides b. If a divides b square, then a divides b. So hope you liked this lecture. This was just introduction of divisibility, and now we would do four or five problems in the next videos. Each video would consist only of one problem, and those problems would be really good, and I would like you to first do not watch the video and try to attempt those problems by yourself. I would also tell you the strategies, the way I use to solve the question, then the way I solve the question, what to look for, what should be your thought process, and everything. Thank you.